Today we want to pick up where we left off yesterday. We're going to look at this chapter 6, section 4, problem 4, where we've defined the antiderivative of sine of 10t as the integral from 0 to x of sine of 10t dt. So we know that this is an antiderivative of sine of 10x. The first thing we want to do is calculate f at pi over 5. And the objective here is just to remember how we plug things into this function. So in this case, the x is pi over 5. So we're going to integrate sine of 10t dt and then evaluate from 0 to pi over 5. This is how we evaluate when we have when we're using the construction part of the fundamental theorem of calculus. So we can actually find the antiderivative of sine of 10t. So rather than going through the whole construction business and not knowing what the antiderivative is, we can actually write the antiderivative. The derivative of sine is cosine, but the derivative of cosine is negative sine. So the antiderivative of sine of 10t is a negative cosine of 10t. But the chain rule would have us multiply by the derivative of the inside, which is just a 10, so we have to cancel that out with a 1/10. So here is the antiderivative of sine of 10t. We can write that explicitly. Then we just have to evaluate from 0 to pi over 5. So in this example, or in this problem, we can actually write down the antiderivative rather than just construct it. Here, we go beyond constructing the antiderivative. We get to find one. So this is how emphasizing how we evaluate functions defined with the construction theorem, but it also reminds us that we sometimes get to find the antiderivative. So here we are finding the antiderivative. That means we're going to plug in the pi over 5. And plug in 0. We're adding here because we do capital F at B, or we do F at B minus F at A. So we're subtracting, so that's why we change the sign there. In this case, we have to look at the cosine of pi. Oh, this becomes cosine of 2 pi. And the cosine of 2 pi is equal to 1. And the cosine of 0 is also equal to 1. So we have a negative 1/10 plus 1/10. So our total is 0. So f at pi over 5 is equal to 0.
Why isn't it 2 if cosine of 2 pi is 1 plus 1?
Because we're multiplying also by the negative 1/10. Negative 1/10 times 1 plus 1/10 times 1. So negative 1/10 plus 1/10.
Okay.
So this represents how much we're integrating the sine of 10t. This tells us how much the cosine of 10t has changed from 0 to pi over 5. So this is the change Now, if we look at the function negative 1/10 cosine of 10t, if we look at the graph of that function, we have an amplitude of 1/10, and it's a negative cosine, so it starts off at the bottom. So we have an amplitude of negative 1/10. And since the coefficient of t is, and what's going to happen, it's going to go up and then down. And since the coefficient of t is equal to 10, the period of this function, so the period, is 2 pi over 10, or pi over 5. So this happens at pi over 5. So it goes back down to the bottom at pi over 5. So here's one cycle. So when we integrate from 0 to pi over 5, we can see that the value of the cosine is back to where it started. So the value of the cosine did not change. So it makes sense that when we integrate the derivative from 0 to x, or sorry, from 0 to pi over 5, we get 0, because the antiderivative did not change on this interval. So here's the graph of y equals cosine, negative 1/10 cosine of 10t. If we look at the graph of sine of 10t, if we look at the graph of sine of 10t, which will be the derivative of this function, so sine of 10t will start off at 0, go up to a 1, down to negative 1, and back up to 0. In this case, the same thing happens. The period is equal to pi over 5. And then here's where we start at 0. And the symmetry of the sine says that the area above and the area below are going to be the same. So that's why we see the cancel. So what happens is we'll see the derivative. When we're looking at the derivative, we'll see negative 1/10 cosine of 10t increasing up until pi over 10, and then decreasing from pi over 10 to pi over 5. And the amount of the area is the amount of increase, and the area is the amount of decrease. And those two areas are equal. So the area under here is the amount of change we see from 0 to pi over 10. So that area must be from negative 1/10 to 1/10. That area must be a total of 1/5. And then the decrease of 2/10 from pi over 10 to pi over 5. Because that'll be the amount of increase. When the derivative is positive, the function is increasing, the area tells you how much it increased. When the derivative is negative, the function is decreasing, the area tells you by how much. So we see that in the graph of sine of 10t, and also in the graph of negative 1/10 cosine of 10t. The amplitude here is still just at 1 and negative 1. Here, the maximum will occur at half the period, which is pi over 10. And that will happen here at pi over 10. Any questions? The second part of the question is kind of strange. They ask you which graph explains that geometrically, and took me a minute to sort out that they're just graphing a bunch of sinusoids, and they're getting certain things incorrect about where, like having you punch things in incorrectly into your function or into your graphing machine. But it's that first one. This is the graph we're looking for. It says select the correct graph below that explains geometrically why your answer from part A is correct. Consider that x naught is pi over 5. So this is the only one that matches, where x naught is a pi over 5 and the amplitude is 1 and negative 1. There's a cosine graph, but the cosine graph has an amplitude of 1 and negative 1. But if we're looking at the antiderivative with the cosine graph, the amplitude is 1/10 because of the chain rule. Any questions? Keep in mind, if we were unable to find the antiderivative of sine of 10t, this is still how we would evaluate this antiderivative. We could still just grab a machine and say, hey machine, what's the integral of sine of 10t, 10t with respect to t from 0 to pi over 5. And then we have to make sure that we are in radians. And it's 0. Any questions? We can also graph this function. We can also graph this function. So, so some DVD bonus material. We can say graph the antiderivative, or graph the integral of sine of 10x with respect to x from 0 to x. TI-84 doesn't mind if you plug x into x. It looks weird when you're writing things out, but TI-84 is okay with it. Mayan degrees. Oh, it's still thinking. I asked it to do too much. You can see it is trying to graph it. It's just going to take a long time because the processor is slow. So it's like plugging things in. It's like, oh, help me. This is too much. And I forgot what to do to make it stop doing a thing. Quit. There we go. Okay. Let's not make it do that. I'm sorry, calculator. That was a lot to ask. Any questions? I was going to update the graphics card on my calculator, but some scalpers went and bought them all. And so now they're reselling them. Or is that PS5s? All right. Any questions? PS5s, toilet paper, graphics cards. We really have strange priorities, I guess. All right. Any questions? Comments? Snide remarks? Cool. All right. I like how everybody's complaining about the scalpers buying up all the PS5s and then selling them at increased rates. And then these same people, when I say capitalism is bad, they all tell me that I'm wrong. I'm like, oh, all right then, that's fine. All right, let's pause the video here and talk about what's next.